Right, moving on to the new chapter, integration. Right, integration, quite a long chapter. It's the longest in the pure maths, up to 11.12. Now, in terms of skills, there are 1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.7, 0.5. I put it 0.7.5 because this is not taught separately in the textbook where they hide it into the finding area. So I just break it out, so it'll be easier for us to learn. So these are the integrating skills that you have to learn, like differentiation. There are some basic skills you have to learn and you're going to apply it. When you apply differentiation, differentiation skills like differentiating parametrically, chain rule, product rule, you can use it in, let's say, finding equation of tangent, finding equation of normal, finding convex, concave. But in integration, these are the skills that you can use it for finding areas and solve differential equation. Yes, there are so many skills, but only for sort of 2 or 3 applications in here, which is trapezium rule. Actually, trapezium rule is not. Finding area, differential equation, and modeling. Now, integration, for anyone have seen it or heard it, it has a really bad name for itself, which is actually true, because integration, unlike differentiation, it is not as straightforward. I know you had to, if you don't love differentiation, you should have, because by looking at integration, you know how much you will miss differentiation. It's like a good soft slice of pizza, cheesy, warm, you love it, and you want to have another bite. That's the same with differentiation. When you see differentiation question, you love it. But with integration, it's the opposite, unfortunately. So, so we are going to go through 11.1 today. Now, with 11.1, what you need is also a formula booklet, okay, with you. So from now on, when you do integration, you should always have your formula booklet with you, because formula booklet is a big part of integration. Sometimes it will give you a hint, and sometimes it's the answer without you noticing. So that's why familiarizing yourself with the differentiation bit and the integration bit. If you do it in Edexcel, that'll be page 6 and page 7, and these 2 parts, which will be extremely essential for integration. Okay, we'll come to it when we need to use it. Right. So let's go back to here. So we'll look at standard results. Okay, so these are standard functions that you have to know by default. So let's go through one by one. Well, based from year 12, you should know this. If you're integrating anything with x to the power of n, you just add 1 to the power and divide by new power. Okay, add 1 to the power, divide by new power, and then we have a plus c. And a lot of people would have forgotten plus c. Don't forget plus c. E to the power of x, to integrate e to the power of x is just e to the power of x. Just one more thing in here possibly is that, what about y equals e to the power of kx? Then then the integral of y dx will equals to 1 over k e to the power of kx. If differentiation you're multiplying by the power, then integration you're dividing by the power of e, or the coefficient of x, and then and then put an e back in, right? What about 1 over x? To integrate 1 over x is ln x, because we know differentiate ln x will give you 1 over x, and plus c. Cos x sin x, these 2 are familiar with the clock. Remember that? The clock thing, where you've got sine, cos, negative sine, negative cos. If you go clockwise, that will be differentiation. But if you go anti-clockwise, that will be integration. Right? So next one, sec squared. Now these 4, okay, these 4 are given in the formula booklet. So these are given in the formula booklet. These 4, nope. So hang on. These 4 are given in the formula booklet. FB is not Facebook, it's formula booklet. So sec squared, if we look at the formula booklet again, sec squared. If you look at the formula booklet for sec squared, integral of sec squared, you would see integral of sec squared is 1 over k 10x. Okay. What about the cosec x cot x? So if you look at the formula booklet again, when you integrate cosec x cot x, if you look at the integration part of the formula booklet, there is no cosec x, cot x. There is a cosec x and cot x separately, but you can't combine them. It doesn't work that way in integration. So where it is, it's actually in the differentiation bit, right? Now, you have learned to differentiate these ones, and these are derivative. So backwards means integral. For example, if you want to integrate sec squared, you get 10. If you want to integrate sec x 10x, it gives you sec x. If you want to integrate, okay, what was that again? If you want to integrate sec x cot x is here. Integrate sec x cos x, therefore it's negative cosec x, because can you see the sign is different? If it's positive, it's negative. So if we want to integrate a positive cosec x cot x, it becomes a negative cosec x. So remember, you will want to use both the differentiation part and the integration part. Actually, the differentiation part is actually more useful for integration than the integration part itself. So, right. So yes, so cosec squared, you want to integrate cosec squared, we can use negative cot x, and sec x tan x equals sec x. You can use this for today, and remember, they're always in a formula booklet. And it's better to get used to the one using in the formula booklet, because that's what you'll see in exam, right? These are not the notes you'll see in exam. You can bring it in, but I'm not sure what, I'm not sure if we get caught, and please don't. So notes. So there are some generic notes I can give it to you, some tips you can use when it comes to integration. Okay, the first one is, I'm going to type it out because my writing, my writing is not the best. The first one is, you want to simplify as much as you can. The font is massive. Simplify as much as you can, or simplify to the format shown in the formula booklet before integrating. That's before integrating. Okay, simplify as much as you can, because with integration, when you use a formula booklet, they must be exactly the same before you can apply integration. So yeah, next one is, you can integrate separately between a plus and a minus sign. So when there's a plus and minus sign, that means you can split out and integrate one by one. Not for times and divide. Plus and minus, you can integrate separately. I will show you what it means in the next example. Okay. Example, part A. Find the following integrals where we have integrate. Oh, actually, a third bullet point. Add a third bullet point for me. I just remember. Okay, add the third bullet point for me. Take out the coefficient whenever possible. Right. Take out the coefficient whenever possible, because the coefficient later on will be a confusing number for you to integrate. But we know that coefficient has nothing to do with the integration, just like differentiation, for example, just like 5x squared. If I have y equal, let's say y equals 5x squared, okay, let's say, if I want to differentiate, I'm differentiating in here. The 5x has nothing to do with integration, differentiation, because when I differentiate 5x squared, essentially I'm just differentiating x squared, which is 2x. The 5 is just tagging along, so 5 times 2x is 10x. Therefore, the 5 has nothing to do with it, really. So the coefficient is just there, but it's not helpful for integration or differentiation. Therefore, we'll try to take it out whenever possible. Right? Let's have a look. Example. Find the following integrals. Question A. Now, for question A, I am going to write it out as small steps as possible. Obviously, when you get used to it, you don't have to write these many little steps. But I thought it would be a good one to start off, just to show you what I mean by these 3 bullet points. Okay, right. So first one, I'm going to separate them. You can see some plus and minus sign. I'm going to split them out. Okay, so I'm going to write integral of 2 cos x dx plus the integral of 3 over x dx minus square root, the integral of square root x dx. Now you can see I split out the plus and minus. That means I can integrate individually term by term. Okay, and the next tip I also tell you is take out a coefficient if you can. Now you can see this 2 is a coefficient, so I'm going to write 2 integral cos x dx. This 3 could also be taken out, plus 3 1 over x dx minus, now this square root is not a coefficient, but we can rewrite as power of a half, because that's useful for integration. Right? Then one by one. The 2 has nothing to do with it. Now integrating cos x using the sine cos clock, integrating cos x will give you sine x. Okay, plus 3 times. Okay, integrate 1 over x using this table. 1 over x is ln x. So ln x. Okay, we sometimes do write the absolute value, the 2 bars, like the magnitude, because you can't add a negative value. Yeah, so it's a good habit to write the bars, but sometimes I forgot to do so. It's not a big deal, but it's best to write down the 2 absolute sign, the 2 bars in here. Minus integrate x to the power of half, add 1 to the power over 2, divide by new power. Where divide that means you flip the fraction 2/3, and then don't forget the plus c. A lot of students would have forgotten plus c. I call this the forgotten child. Okay, just like you leaving the basket of a child in the river waiting for someone to pick up. Bad parent. So plus c, don't forget the forgotten child plus c. So that's part A done. Okay, part B, integral of cos x sine squared x. So let me copy the question again. So the question was integrating cos x over sine squared x minus 2e to the power of x plus dx. I see a minus, so the first thing is, again, I'm going to rewrite that thing. The first fraction, split them up, dx minus. Now this time, I'll also pull out a 2 in one go as well. Right, so remember, you should pull out the coefficient whenever you can. Now, the second function is easy to integrate because integrating e to the power of x is just e to the power of x. What about the first one? The first one. Now, there's no such thing known as quotient rule in integration. All right, differentiation, we love it because we can either follow chain rule, product rule, and quotient rule. Okay, we love to follow something. But integration, we can't. Okay, we're now off to something that we have to try to work it out. So if I tell you, okay, pause the video. Okay, if I tell you there's something to relate on this column, okay, left side in this table, okay, think about which one can this change it into? Can our expression change into something into this side of the table? You can pause the video, work it out, think of it. Okay. Now the answer would be, okay, the answer would be, now if you look at this table, it's definitely not these cos, sine, and sec squared. Well, why? Because this is a composite function. You see a cos over sine squared. So there's more than one trigonometry term in there. So therefore, it's definitely not these 3. So now if you look at the next 3, they are cosec and then sec as well. So in other words, we're going to try to change it into, what's the word again? We'll change it into reciprocal function. So cos over sine squared, I'm going to rewrite as cos over sine x times 1 over sine x dx. Now, see what I've done in here? I've not integrated anything, so I keep the integral sign. I just split the fraction inside the integral sign and the dx. Right? Next one, I integrate e to the power of x. It's just e to the power of x. So when I've integrated that one, then I can get rid of the integral sign. And that's why I tell you to split them up, because then you can do 2 things in one go. 2 things in different stages. You don't have to integrate the whole thing all together in one step. It's not like year 12 integration. You can't, sometimes you can't integrate the whole thing in one go. Some terms are definitely harder than the other term. For example, in here, the first term is definitely a lot harder than the second term. But we also have the plus c. Okay, once we finish integration, we'll put a plus c at the end, so we don't forget that. Right, so cos x over sine x, okay, is cot x. 1 over sine x is cosec x. Dx, because I've not integrated, I'm just simplifying, minus 2e to the power of x plus c. Now cot x, cosec x, using the formula booklet, is negative cosec x. So here, we go to negative cosec x. Now I'll suggest you in here, so from formula booklet, if you can write down where exactly on the formula booklet to remind yourself next time when you look at it, you know where this comes from when you read it again. So from formula booklet, negative cosec x, okay, minus 2e to the power of x plus c, and that's the end. How do you double check your answer? Well, you can try to differentiate it. Okay, you've learned all the skills to differentiate, and you should get to the original question. Okay, right. So example, next one. This time we are going to integrate with a range. We call this a definite integral. So A definite integral simply means we're integrating with a range. In here, you can see a and 3a. That's called definite integral. It's definite because when we integrate, we'll get a numerical value. Okay, we are working out an answer. So that's why it's definite. Right, so to integrate that one, you should know from year 12, when you integrate with a range, it means you want to sub in at the end, the bigger one, subtract the smaller one. So given that a is a positive constant, and the integral of a to 3a, 2x plus 1 over x dx is ln 12. Find the exact value of a. So let's integrate. Now, you see a fraction. Normally in differentiation, you'll be thinking about, let's do quotient rule. There's no such thing. What we need to do in here is actually, why don't we split the fraction? Okay, and that equals to ln 12. So 2x and x cancel out into 2, 1 over x. So it's just integral of a to 3a of 2 plus 1 over x dx equals ln 12. Now, this term, you can split them up because there's a plus sign in the middle. But this is quite a simple expression, so we don't need to do all that shenanigans. We can just integrate straight away. 2 is 2x. 1 over x, you remember? It's ln x. And then we'll put a and 3a. That equals ln 12. So we need to sub in 3a and a in there. So let's sub in 3a. So it'll be 2 times 3a plus ln 3a. Now with this subtraction, I would suggest you put a big bracket around it because you never know, the minus will mess up the sign inside a bracket. So 2a plus ln a equals ln 12. Next, let's simplify it. 2 times 3a, 6a plus ln 3a minus 2a minus ln a equals ln 12. Now, if you know your logs and confident with your logs, I would suggest you pause the video and try to finish the value, try to finish off the question. Okay, actually, if you're not confident, you should try it because you should know this. Okay, pause the video, finish it off. If you can't, you can carry on with the video. So 6a minus 2a will be 4a. Okay, I see a plus ln 3a minus ln a. Log a minus log b equals log a over b equals ln 12. Okay, so a and 3a cancel out. So 4a plus ln 3 equals ln 12. You can bring the ln through on the right hand side. 4a equals ln 12 minus ln 3. Again, log a minus log b is the same as log a over b. So 4a equals ln 4. So a equals, divided by 4, a quarter of ln 4. Now, we usually, when we write ln, we write, if there's a fraction in the front, we write a quarter of ln 4. We don't usually write ln 4 or 4 like this. Okay, we don't usually write this. If you can, we usually write the coefficient in the front. Can you simplify this? Yes, you can, because 4 is the same as 2 squared. So if you use the log rules, you can bring the 2 down. It'll be a half ln 2, and that's perfectly fine. So, either one of them is fine. Okay, and that's the end of chapter 1, 11.1, where we are using the formula booklet.